Hello, so I'm doing packet scheduling, and essentially packet scheduling is just algorithms that allocate router resources among the packets of flow and between competing flows. And among this, there are just three different kinds of resources that are reserved amongst these algorithms, and that is bandwidth, buffer space, and the CPU cycles. And within the packet scheduling system, there comes one major playstyle that is going to be followed, and that's FIFO, or first in, first out. And just another name for that is FCFS, which is first come, first serve. And what this means is that the oldest entries of all the queues that are in the queue, the query waiting, are going to be processed first. And this is where fair queuing comes from. And in fair queuing, routers have separate queries for each input, or queues for each input, input line. And each host will be able to send out one out of every n packets. So this way you don't have one router overloading the queries at all, queues at all. And each input queue will take turns sending out the oldest packets in line. So if you look here, it's going to go from this one. It's going to go like 1, 2, 3. It's going to say 1, 2, 3. And because there's no 2, it's going to go 1, 3. So essentially it's going to go down the list. So that way it's not doing like 1, 1, 1, then 2, 2. Because then these ones are going to be waiting way too long. So it's just a way for that to go into order. And so for this, QoS routing, it's where the network decides whether to accept or reject a flow of packets, and it's going to reserve space for all these packets. And what this does is this guarantees new flows may still be accommodated by choosing a different route for the flow that has excess capacity. It can also split the traffic for each destination so it's not overloading anything. And a simple method easily is just for routers to choose equal cost paths and to just divide the traffic equally so that nothing's being overloaded. And this is where flow specification is. So it's just described accurately in terms of specific parameters that can be negotiated. And so the sender would typically be the one who produces a flow specification proposing that parameters it would like to use. And so here you have a simple example where this is typically just something that some parameters may consist of. So you have the rate and size, and the rate is just the same rate a packet might be in, and then the large is just the packet size, just the largest burst anything could be. And then the peak data rate is just the maximum transmission rate that anything can be processed in. And then the minimum and maximum packet size are just the minimum packet size that can be sent. And then here you have integrated services. And this is where RSVP, the resource reservation protocol is here, is used for making reservations while other protocols will send the data. And this allows multiple senders to transmit to multiple groups, individual receivers to be able to switch channels like freely. And this eliminates any type of congestion. So here in this example, you can see 1 and 2 are out here trying to transmit a lot. And you can see that they're just crossing all these channels and others to get to these receivers. So what this will do is it will just allow senders to overlap. So you have 1 and 2 going down and on the same level. And so what this does is it's basically saying that 2 is going to take the same path as 1 to get down to 3, 4, and 5. So instead of having 2 bounce around all these, it's just going to go, they're both going to stop here. It's just the same path. Same thing as this one over here. It's just the opposite, as you can see. And then my question is, what is fair queuing?